In this video, we'll look at a quick introduction to polar equations. So we'll begin the video by reviewing what polar coordinates are and how to convert from polar to rectangular and rectangular to polar. But then we'll look at two examples. One, how to convert from rectangular to polar equations, and then one, converting from polar to rectangular. So remember that the polar coordinate system uses the coordinate pair r theta to define a point as opposed to x, y in rectangular. For r greater than 0, for positive r, you trace out the angle theta and then draw out the length r. For r less than 0, you trace out the angle theta and then go the opposite direction, the length r. For theta positive, we go counterclockwise, and theta negative, we go clockwise. We use the equations x equals r cosine theta and y equals r sine theta to convert from polar to rectangular. And to go the other way, we use the Pythagorean theorem and the definition of tangent to find r and theta. So let's express the equation x squared equals 4y in polar. So first I should tell you what an equation in polar coordinates might look like. By convention, we'll try to write them as r equals something, just as we try to write y equals something. But you may also see theta equals pi over 3. That's a legitimate polar equation, just as x equals 4 is, or y equals 2. We may also have something that's like r squared equals sine theta. And often we have equations that look like y squared equals x. These are all valid forms of a polar equation, although we'll try typically to write them by convention with r equals whatever. So now remember that x equals r cosine theta and y equals r sine theta. To convert from rectangular to polar, we simply just take this equation and pop that into what we have, the equation in rectangular. So we'll have r cosine theta squared equals 4r sine theta. So we have r squared cosine squared theta equals 4r sine theta. One of the r's cancel. We divide over by cosine squared, so we have r equals 4 sine theta over cosine squared theta. And just to kind of see what's happening here, I'll rewrite this as sine theta over cosine theta times 1 over cosine theta. So r equals 4 tangent theta secant theta. And these two equations, x squared equals 4y and r equals tangent theta secant theta, are equivalent in the two coordinate systems. Going the other direction may sometimes require a little bit more thought. So express r equals 5 secant theta in rectangular coordinates. So first, remember secant theta is just 1 over cosine, so we can say r equals 5 1 over cosine theta. Now, the trick to going the other direction, or one of the tricks, is to look for things that might become r cosine theta, r sine theta, or could substitute in for x squared plus y squared. We'll look at an example where that's the trick we need to use in a moment, but hold on to the looking for r cosine theta here. Multiply both sides by cosine theta, and we have r cosine theta equals 5, and r cosine theta is just x, so we have x equals 5. So turns out, as you're probably beginning to visualize now, that the equation in polar, r equals 5 secant theta, is just a vertical line. More on that later, but a nice little preview. So now express r equals 2 sine theta in rectangular coordinates. So the first thing that jumps out to me as maybe being the obvious first step is multiplying both sides by r. So we have r squared equals 2r sine theta. Now, multiplying both sides by r is going to be one of the useful tools for you to use to convert from polar to rectangular. See, now we have r squared, which we know by Pythagorean's theorem is just x squared plus y squared. And we also identify r sine theta as just y, so we have 2y. Now, if we move everything over to one side, we have x squared plus y squared minus 2y equals 0. The reason I want to do this is so it becomes clear kind of what's going on with r equals 2 sine theta. So now let's complete the square for y. So we'll have x squared plus y squared minus 2y plus 1 equals 1, because we have to add it to both sides there. So we have x squared plus y minus 1 squared equals 1. And we know that this is the equation of a circle that's centered at the point 0, 1. So the equation in polar, r equals 2 sine theta, is a circle centered at the point 0, 1. Kind of cool. So this may be a useful analysis for us to do when we begin to actually graph equations in polar coordinates. It's important to also note, as a sidebar, that when we convert from polar to rectangular and rectangular to polar, it may not always be really nice, which should tell us that maybe it's most useful to use polar for certain situations and rectangular for other situations. So now we have to start looking for those particular situations, but in the meantime, we'll get a little practice in, and then we'll begin to graph polar equations.